Let's walk through the most important machine learning algorithms with real-world intuition and practical examples. Let's begin with linear regression, one of the simplest and most widely used algorithms. Imagine you're trying to predict the price of a house based on its size. You collect past data, square footage and corresponding prices, and plot them on a graph. You'll notice that as the size increases, the price generally increases too. Linear regression draws a straight line through those points in such a way that the overall error between the predicted values and actual values is minimized. That line becomes your model. Now, if a new house comes in with a specific size, you can use that line to estimate its price. This is widely used in forecasting, like predicting sales, stock trends, or even temperature changes over time. Now let's move to logistic regression. Despite the name, this is not used for predicting continuous values. Instead, it's used for classification problems, especially binary classification. Think of a bank deciding whether to approve a loan application. The output is not a number like price, it's a decision, approve or reject. Logistic regression calculates the probability of an event occurring and maps it between 0 and 1 using an S-shaped curve called the sigmoid function. If the probability is above a certain threshold, the outcome is classified as yes, otherwise, no. This is commonly used in fraud detection, spam filtering, and medical diagnosis. Next comes decision trees, one of the most intuitive algorithms because it mimics how humans think. Imagine you're deciding whether to buy a laptop. You might ask questions like, is it within budget? Yes or no. Does it have enough RAM? Yes or no. Based on each answer, you move down a path until you reach a final decision. That's exactly how a decision tree works. It splits the dataset into smaller and smaller subsets based on conditions until it reaches a decision point. Decision trees are widely used in business applications because they are easy to visualize and explain to stakeholders. Now let's talk about support vector machines, or SVM. Imagine you have two categories of data points. For example, customers who bought a product and those who didn't. You want to separate them with a boundary. SVM doesn't just draw any line, it finds the optimal boundary that maximizes the distance between the two groups. This distance is called the margin. The larger the margin, the better the separation. SVM is particularly useful when dealing with complex datasets where the boundary is not obvious, such as image classification or text categorization. Next is k-nearest neighbors, also known as KNN. This algorithm is extremely simple and works based on similarity. Imagine you move into a new city and want to guess what type of neighborhood you're in. You look at your closest neighbors. If most of them are families, you assume your area is family-oriented. KNN works the same way. When a new data point comes in, it looks at the closest K data points and assigns the most common label among them. While it's easy to understand, KNN can become slow with large datasets because it needs to calculate distances for every prediction.